So let's just create, let's call this geometry. Okay, let's see. No, not the new folder, new file, geometry, and then let's just call it. And here we're going to export class quad geometry. And here we're going to have constructor. And what are we actually going to need? We're going to have some public positions, which is just going to be JavaScript array. So it's going to be of type number. Then we're going to have colors, and then not the indices, actually rather texture coordinates. So we can just say texture coords, and then we need to rip off this from here for our positions. Then for the colors, we're also going to rip off from here. Okay, I accidentally pressed save, which broke it. And now we're just going to have texture coordinates, and we can specify it like this. We're going to deal with it a bit later if something is wrong. So even if these are wrong, we're actually going to tackle them later. And then here in our main, now that we have geometry, we can actually import the geometry. Import quad geometry from geometry, exactly. And here we're just going to create a geometry. New quad geometry. And then in here, get rid of this. So we're passing geometry positions. So here we're passing geometry colors. All right. So now it works. And while we're doing that, let's create our buffer for texture coordinates. Texture coords buffer of GPU buffer. And we can just specify it here as well. Text code, not texture buffer, text coords buffer. So for texture coordinates. And perfect. Well, we're still not using them. And now we have to actually deal with our shader. So here, so let's just create, let's call this geometry. Okay, let's see. No, not the new folder, new file, geometry, and then let's just call it. And here we're going to export class quad geometry. And here we're going to have constructor. And what are we actually going to need? We're going to have some public positions, which is just going to be JavaScript array. So it's going to be of type number. Then we're going to have colors, and then not the indices, actually rather texture coordinates. So we can just say texture coords, and then we need to rip off this from here for our positions. Then for the colors, we're also going to rip off from here. Okay, I accidentally pressed save, which broke it. And now we're just going to have texture coordinates, and we can specify it like this. We're going to deal with it a bit later if something is wrong. So even if these are wrong, we're actually going to tackle them later. And then here in our main, now that we have geometry, we can actually import the geometry. Import quad geometry from geometry, exactly. And here we're just going to create a geometry. New quad geometry. And then in here, get rid of this. So we're passing geometry positions. So here we're passing geometry colors. All right. So now it works. And while we're doing that, let's create our buffer for texture coordinates. Texture coords buffer of GPU buffer. and we can just specify it here as well. Text code, not texture buffer, text chords buffer. So for texture coordinates. And perfect. Well, we're still not using them, and now we have to actually deal with our shader. So here, let's pass our. So we will just pass it to fragment shader from the vertex shader. Our texture chords, vec2. It will be of type vec2. And here, we still need to get it from the CPU. So we use texture chords, and then we can just say output. Texture chord is texture chords, and it's broken now. We're going to fix it in a bit later, but anyway, let's see here. So now bear with me, since we're going to cover this actually in details a bit later, but we're going to have something called texture sampler, and it's going to be of type sampler. And here we actually need to specify some attributes, and it's going to be in group 0, and it's going to be at binding 0, sorry. And then we will have group again that, but here actually we're going to specify our texture 2D F32. So so first of all, what are these variables? Well, this one is easy, texture 2D. It's just our texture, and the sampler is just an object that allows us to say how are we going to filter texture, how the texture is going to act when it's minified, when it's magnified. It's basically also can specify anti-aliasing. We can say no anti-aliasing. We could say linear or bilinear anti-aliasing, etc. There aren't that many options here, but there are some. So sample is just that. It's essentially objects which says how should we sample the texture, how should we sample texels from that texture, and group 1 here and binding 1. We're actually going to cover it a lot in next video, but it's just like we had to specify here and describe these things. We also have this idea of uniforms or some data that we pass to the CPU, but it's actually not related to our geometry. And here we will also use this, for example, for matrices, right? We might have camera, and camera might define view matrix, and might define projection matrix. And so this is actually data that we're going to have for every material, almost every material. And the idea being here, we can specify that data once and then reuse it in multiple shaders or multiple pipelines. Anyway, it's a bit more involved, so that's why I'm going to have the whole video just on it next time. And here, so now that we have that, almost forgot, we actually need to use our texture, and we can say here, let's say, how should I do it? We can say var texture color, and that's going to be of texture sample. So here we have built-in method or function into our shader, and then first argument is texture, then we paste the sampler, and then finally texture coordinates. And this is our color of our well, basically a texel, and texel is just pixel from a texture that we want to render, and then we can just multiply it here. You could also just get rid of color here and then just have a texture, but this might give us some nice effects, which I'm going to cover later as well. And now we actually need to create our texture, and that is also going to be in a separate class because we also have to handle loading of the image. So let's actually, so here let's just create a new file. Let's call it texture. Texture this, and here we will also have to export it, class texture. And our actual texture is just going to be sort of a wrapper class for stuff that we need to render texture. And that's, like I already mentioned, we're going to have this idea of texture. So it's going to be GPU texture. And we had a sampler as well. Sampler, and that was GPU sampler. So these are actually what's in shader exactly here. Okay, and then now it gets a bit more interesting because we're actually going to have method which is going to be called, what did I call it in my examples? Yeah, it's just going to be create texture. So it's going to be static, async, and let's call it create texture. And here we're going to need device. So our interface to the GPU, and we can just say image HTML image element. And what we're going to return is a promise, and it's going to be our texture object. Maybe I can break this into or rather I should do this. Yeah, that's a bit better. And here. So now how do we create a texture? Well, we can just say texture is this. Sorry, not this device, create texture. And the arguments here, it's going to be size, but this is wrong suggestion. So width, it's going to be our image width. And then height is going to be image height, and depth, I don't care about it. So format, I think this is self-explanatory. Format as well, we already mentioned it. So red, green, blue, alpha. And then usage. So here we're going to have texture binding and the render attachment. So just some flags that we need to pass. So our copy destination, we're copying the destination. It's going to be used as texture binding, and we're actually going to use it for rendering. And then const, we actually need to get data from our image, and there is already JavaScript function for that. Get image bitmap from image, and then we can actually add our texture via device queue, copy external image to texture. That's how the method is called. We provide our source data. Our destination is texture, so self-explanatory as well. And then we can just create our sampler via device create sampler. And here we don't have to provide arguments, but we can also say make filter, min filter, linear. So we're going to cover that in future. For now, actually, I'm just going to leave it at default. So no arguments here, since we're going to cover it later. And then we can just return our texture. This work, new texture. My mistake. Actually, let's get rid of this and do it like this. Public texture, GPU texture, and then sampler. So it's same as saying public texture here. You don't have to type this. This would be, if we provide public here or any access modifier, it's same thing as saying this texture equals texture from the arguments. But I'm going to use public here so that I don't have to do that. So a bit of syntactic sugar of TypeScript, and then that's it. But we also need to actually load the texture, load our HTML image. And so we're going to have another method, also static async. And here we're going to call it create texture from URL. That's fine. And then we actually need to load our image. So we need to create our image, new image. I'm not sure why these suggestions are going so wild, but we're going to have image on load, and actually I need to do this first. New promise. It's going to return an image. So wrap that in a promise. Since it's async and we're returning a promise, we can resolve that promise, and we can say here image. So if you're not familiar with TypeScript or JavaScript, promise is similar. It's similar to task in C Sharp, but that doesn't explain that much either. But essentially, it's something that if it's awaited, it will be resolved in future. And you can create a promise like this. Then it has two callback arguments. So this is just a callback function. It takes resolve and it will essentially be resolved once we call resolve on object. And then we can also reject it. But here we're going to have callback actually. So if something is wrong, if it's not loaded for any reason, we can actually just say fail to load the image and provide a path, then reject the promise. And here we're actually going to await it. All right, const. Aha, I forgot to close it here. And then we're actually going to call this method here with our image. So it's just a helper function that will actually load the image and then just call this with the image. Okay, with that said, now we have to deal, actually we have to load our texture. So let's just call it test texture. It's of type texture, or we have to import it here. And then our test texture, we can load it somewhere here, it doesn't matter, is going to call await texture. And then this is not test PNG, it's actually, sorry for this, let's see, it was called UV test. It's still not working because there are still some steps that we actually need to do, and we're going to do them now. Like I said, this video is a plenty of steps to actually load a simple texture, but anyway, it is what it is. Here, as you remember, we had layouts for our position, send colors, and now we need to provide texture coordinates layout as well. It's of GPU vertex buffer layout, same as this guy here. And our stride is actually 2 times bytes per element, 2 because it's vector 2. Then we had this shader location is actually 2 now, if you remember that we specified it 2. So here, and this is pretty much the same. You already get this part probably really well by now. You know, it doesn't even matter because it's just a matter of practice. Then we can say this here, and we need to pass it as well here. Texture codes layout. Still not working because there are still some steps that we need to do. Now the next step is actually we will need to specify our, if you remember, I mentioned here that we have these guys and we actually need to describe this group and binding to our pipeline. So let's do that. So somewhere over here, after fragment state, we can actually create that layout. We could say texture bind group layout, and it's called via device. So create bind group layout, and here we will have entries. So binding 0 is going to be our, if I remember correctly, what was binding 0? It was our sampler. So we're going to specify sampler here. It's visible in fragment shader, and then we can just say sampler and provide empty object here. Second one is going to be binding 1, if you remember. So this is our group 0. This is how we define group. So if we wanted to do another group of uniforms, we would say group 1, group 2, etc. But that's also something that we're going to cover. So here, last argument is actually texture because we're providing texture. It can be just an empty object, and then that's it. We have our texture bind group. So now we're going to create pipeline layout. So we're going to use that texture bind group layout. And here we just need to close it. But we're also going to need something called texture bind group. And with the texture bind group, we're actually going to use it somewhere in the draw. The texture bind group is actually going to hold our texture. So this is just description to the pipeline, but now we have to define what pipeline is going to use. And actually we can do that here, private, and it's going to be texture bind group. And here the type is not GPU buffer, it's rather GPU bind group. And so let's create it now. So right after pipeline layout, since we're actually going to need the pipeline layout for the bind group, right here, as you can see, the first argument is layout, and then we have entries as well. So our binding 0, what will it be? It will be our test texture sampler, right? The binding 0, if you remember, we said that it's actually sampler, and that's also in shader as well. So binding 1 is actually a texture, or texture view rather. Alright, now we have our texture bind group. And for layout, here we previously had auto, but let's actually get rid of it. So because we now created our pipeline layout, we can just pass it to pipeline. And it's still not done because we actually need to use it in a draw method. Basically, how should I explain it? But basically, it just has to do something with our alpha channel. If you remember, here we have alpha, and we're actually going to cover that as well in one of the next videos to much greater extent. But here we just need where we defined our fragment state. We actually need to define how do we blend. How are we actually going to blend, and what are we blending? Well, basically we have our where are you? This thing. Well, if you remember from one of the last lectures, we have our frame buffer. That's what was already. Let's say that we had some sun here rendered, right? Tree, whatever, and then we have some texture. It might be this texture, or it might be whatever. But we actually need to apply that texture now to the scene. It might be somewhere over here. It doesn't even matter. And the point is, with blend, we actually specify what to do with these values. And what does that mean? So basically, if we have our texture and then we have our scene, so what should texture do when it's applied to scene? What should we do with alpha? Well, how should we interpret red, green, blue channels? How should we edit? Should we subtract it? Should we multiply it? What do we do with those all of those colors of the two textures? And that's what's specified in blend function. So we can say here, for example, source factor. It can just be, let's use 1. Then destination factor, let's use maybe 0. I'm not sure if this will work. And I forgot something. It's actually not just like this. It's color. And then we're still missing. Let's just format this a bit so that it looks nicer. And then we still need to specify what to do with alpha. And I can just copy this because it's actually kind of has the same values. So nothing changed, but if I change this to 1 minus source alpha, you can see here it actually works. It's just that our texture is upside down. We can also do it for here. It doesn't have effect. But how does this work actually? Well, I'm going to explain it later, as I already mentioned, but just a quick note. So let's have an S, which is our texture, and actually let's use S as our texture. It's source, and then we will have our T target, which is actually this whole scene, right? And everything behind the texture, because texture is currently being applied. So what does this do? Source factor, destination factor operation, right? Well, it basically says source factor, so it will be source times 1, and then we have 1 minus source alpha. So it will be, and operation is add, so we're adding, and then we have target, and then we have 1 minus source alpha. So it's multiplied by 1 minus source alpha. So let's just say s dot a, and that's our final function. So here we can specify our function, and if, for example, I change some value, we will get different result. So for example, here I could just say 0, and it's black. Why? Because our source alpha here is now 0, and this is basically 0, and 0 plus this here. So since source alpha is actually here 1, it's actually using original color, but here, no, sorry, vice versa. Here source alpha is 1, so 1 minus 1 is 0, so target is 0, therefore it's black. Okay, maybe I should just remove here, just to explain it once more. So we had source times 0, which is basically 0, and then we had target, and we had 1 minus source alpha, for example, but the target here it was 0.8, right? If you remember, 0.8, 0.8, 0.8, therefore we get 0.8 here. But here, and alpha, this texture isn't covering this part, or isn't covering this part inside either. So here alpha is just a 0. So 1 minus 0, it's using original color from our target. But here alpha is 1 in these black regions. And so it's 1 minus 1, therefore target times this is actually 0. Therefore everything is black. So hopefully you understand that. Like I mentioned, we're actually going to play more with these values in the future. It's kind of complex, and it's a bit easier when we have multiple textures to show, because then we can compare between the textures instead of scene. So that's a bit better. And last thing that we have to address is actually our texture coordinates and why it sits upside down. So, but that's easy to actually fix. We just here for y's we need to reverse them. So we can say here 1, 1, 0, sorry, 0, 0, and 1. And it's fixed now. So now it's in correct format. And here, if you see a bit of aliasing here on this line, you can actually go to texture and specify where we had sampler, mouth filter, linear, or min filter, linear. So now it should be a bit better, but it's also something that we're going to cover in the future. So that's it for this video. Next video, we're actually going to use some matrices to move our coordinates from -1 to 1 space to something that's a bit nicer to work on, especially in a game. And we're actually going to cover these bindings quite a bit next time. So that's kind of important. So we need to cover that. And hopefully you enjoyed this video, and until next time. Sorry, one more thing, I almost forgot about this. I was ready to stop recording, but then I remembered because the colors here don't seem all that correct, because here you can see the texture, the blue is really blue, the purple is here completely mixed, and that's because actually we're multiplying in our shader with colors. Here, if I just say here use texture color, it's going to be correct, but actually I don't want to use that because I do want to have, oh, what's wrong? Okay, I did something here instead. I don't want to do that. I actually want to play with these colors maybe in the future. So we will leave it as is, but here in geometry, instead of specifying everything as different colors, we can just use 1, 1, 1 everywhere. So we need to do this 6 times, 2, 3, 4, 5, 6. So this is white, and now it's correct actually. So that was it if you wanted. All right, that's it. So until next time.